a joint, and you have to join by a frictionless pins. Pins means that will become a nut and bolt arrangement, or rivet will be there, or mainly these two types is there. Praveen Dikshit. Praveen Dikshit. Praveen Dikshit.
Yes, sir. Yes, sir.
I am audible?
Yes, sir. Yes, sir. My mom just entered the room. That's why I couldn't reply first.
Okay. So for the analysis of the truss, the term joint comes into the picture. The joint is a structure, is defined as a connection where two or more members are fastened together. So when we will tell that joint A is there, joint B is there, so you have to imagine at that point a connection is there where two or more members are fastened together, that you have seen in the airport, that you are seeing the rod, 2-3 straight members are joined on the last point. What it then, it makes the flat end, and then they drill it, and in that one bolt and nut arrangement are done so that it becomes tightened. So this is about the truss. So what is the elements of the truss? So elements of the truss is the cords. So these are the members which forms the outline of the truss. Verticals, the members are, some are the verticals that you will see the right angle triangle. Okay, so one member is the vertical. Diagonals means suppose that a parallelogram is there, or in this one we will there, so the diagonals are also inclined because you have to convert into a triangle. So these are the parts of there, it will be written. And types of truss is there. So here you have to study only about the simple truss. Okay. That depends upon the geometry and different types of the complex truss, simple truss, compound truss, but you have to study only about the simple truss. So what is a simple truss? It is a rigid plain truss which can be formed from a basic triangular truss, because you know that truss will be measured in the form of the triangle. So it is a rigid plain truss. Plane meaning one plane will be there, you have to analyze, which can be formed from a basic triangular truss by appropriately repeating the addition of two new members and a one new joint at a time. How it will be formed? It is a triangular truss by appropriately repeating the addition of two new members. Okay, if you will see the triangle, that one point is there, every point you are seeing the two members, and when you will add it, two new members or add a new joint at a time. So two members will be there, then a joint will be formed, and in this way three member will come. Means if you have to extend it, then again you have to make a joint there. So that will goes on. So sequential new members will be added and joint will be formed. Okay, so this is called about the simple truss. Okay, so some assumptions is there for analyzing of the truss. What you will do in the analysis? So first you know about that one. Truss members are connected with frictional pins, that I have discussed about that one. So pins are used to joint the members, and no pins are frictionless, that you are knowing. So a heavily bolted or welded joint is very different from a frictionless pin. Means what is there, if you will put a pin then what will happen? When load will act, it will just slide. So displacement will be very, very less, but it will not bend from that one point. This is the one.
Sir, it's getting a
assumptions.
bit difficult to imagine the structure. Can you please show us?
I am showing you.
Because there is
Just
no
I am
visible
showing
result,
you.
sir.
I am showing you the figure. Just I am
Thank you, sir.
sharing these slides. Just I am discussing about that these things you keep in your mind. When I will show, then you don't miss it. That's why I put you. So
Okay,
first
sir.
2-3 things you have to keep in your mind. So, and truss members are straight. Also previous I have repeated, again I am repeating. So truss members are straight. If it is not straight, then what will happen? The axial force would cause them to create the bending moment. Then torque will be generated from that one point. And next assumptions you have to keep in your mind. 2 assumptions I have discussed. Truss members are connected with frictionless pins. Maybe the friction will be there, but your assumptions is there. You are assuming it. Practically, it is not possible. When the structures are made, creating, they are incorporating. But for your analysis, for the plane truss analysis, you have to assume. Otherwise, the equations will become very lengthy. So for solving of that one, that is not related to your class. That's why plane truss you have to analyze. In the plane truss, these assumptions you have to make. First assumptions, truss members are connected with frictionless pins, means between the joints where you're connecting the joint, and by the bolt and nut arrangement there is no friction. Means there you have to know force is acting, that you have to keep in your mind. And truss members are straight. And the displacement of the truss is very small. And loads are applied only at the joints. These are the 4 assumptions. What is the assumptions? Praveen Dikshit, can you tell me? Dikshit? Praveen Dikshit?
Yes, sir. Yes, sir.
Can you tell me what 4 assumptions I have discussed?
Sir, actually, I am not focused so much. I can't.
That's why. If I will show the slides,
Yes, sir. You
then
will show it.
just you will only see. So before sharing, I discuss
Sir,
about
sir,
that.
sir, with
Ranjan
only,
Tiwari.
only
Okay,
hearing,
okay, no
it
problem.
doesn't.
No
I can't
problem.
imagine without seeing anything.
No,
It's
no.
hard to imagine.
Just I have discussed about the 4 assumptions. What is the 4 assumptions? You are knowing that truss is made only, truss is a structure, and that will made in the form of a triangle, and all members are straight. So these things you have to take in your assumptions previously, whatever I have discussed. That joints, when you are joining and joining by the nut and bolt, there is no friction. That's why truss members are connected with frictionless pins. Truss members are straight. Why it is straight? Because if it will be bent, then axial force would be cause them to create the bending moment. And displacement of the truss is very small, and loads are applied only at the joints. Gyan Ranjan Tiwari? Gyan Ranjan Tiwari? Gyan Ranjan Tiwari? Gyan Ranjan Tiwari?
Yes, sir.
Tanmay, can you tell me what are the 4 assumptions?
Sir, the 4 assumptions were about truss, that how can we manage to solve the problems about the truss?
Truss.
Yes, sir, truss.
So what are the 4 assumptions I have discussed? Tanmay Raj?
Sir, Sir, actually, I told you now, sir. Actually, it was getting really difficult for me to imagine the structure. That's why I was unable to follow.
चल Is a screen visible to you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, wait for some time. So you see, this is a truss.
Sir,
This is the analysis. This is a truss. This is a truss. No, just I am showing you the figure. See here, this is a triangular systems. You have joined this by in a triangle way. This is a rectangular, but you have to join the diagonal because 3 members should be there. Okay, this is the first point, a starting point. So you have made it is a hinge joint, and this is the roller joint. You have joint and you have put the roller on the support. Then what will happen when load will act? This is a structure member, or suppose that the vehicle will pass here. 50 ton, 60 ton, 100 ton loads will be passed from the here. Then what will happen when extension will happen? 0.0001 elongations will be created for every load. Then what will happen if you will not give this gap? Then what will happen? It will, after a certain period of time, it will get cracked. You are seeing on the bridges that they are creating, and between the two supports or two pillars, when they are either concrete structure is there or whatever structure is there, they are giving some gap. So that in our country, in winter time, you are seeing the 4 degree, 5 degree temperature is there, and winter time 45 degrees there. So that is made through the material, iron rod in the side will be there, and other materials will be there. So when that contraction and expansion will happen, slightly will get happens. If you will not give the gap, then what will happen? It will get cracked or it will bend. That's why we are giving the here roller support in the steel structure, or here we are clamping it so that by the bolt it will get in some directions. Okay, so this is the structure. Just imagine like a bridge, and in the airport you have seen the roof of that one, and in any structure, in any industry, the roofs you are giving, that is a truss. Is it clear to you? Is it clear to you?
Yes, sir.
yes, sir.
This is the simple truss I have discussed about that one. Okay, so these are the assumptions that we have discussed about that one. That truss members are connected with the frictionless pins. That see here we will discuss that the frictionless pins means C joint is there, that is the connected, and that is connected by a pin, and between the member and pin there is no friction. Practically it will be there, but for our calculation here no friction is there between the members. Whatever the load will be here, if this load will transmitted here, no reductions will be there, means friction forces is not acting. Okay, is it clear to you? And second is the members are straight. All members are straight. All members are straight. There is no bending in that. You have also seen in the airport structure is there. And displacements are very, very small. That's why we are putting the roller supports. Whatever displacement will be there, just it will get slided. And loads are applied only at the joints. See here, loads are applying here, 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 here. This is the reaction force. Which will this will act that we have discussed in the last class. Here. Okay. No, in the member only at the joints you have to calculate the force. Between the member you have not to calculate the force. Means whatever the forces in the member will be there. Suppose that if C point is there, CA force whatever will be here, that will be here. Okay. Is it clear to you?
Yes, sir.
Is it clear to you? So just what is the plane truss? That I have discussed. Again, I have written in this one and I will discuss. Analysis of truss is the process of finding the force in the member of a truss. You are knowing that what is a member? This is a member. Okay. And made in the form of the triangle. So all three sides will be the member. So analysis of truss is the process of finding the forces in the member of a truss. A framed structure is an assembly of a number of bars or rods, straight, joined together in such a way to form a rigid framework. This structure is designed to resist geometrical distortion under any applying loading, either in the breeze, or you are seeing the rooftop, or some structure you are creating. The ends are joined by riveting, somewhere welding. Means six, seven members you weld it, and after one member you put the rivet, or after so many members you put the bolt. Then what will happen? Lots of a small structure will become a suppose that this way. Suppose if you are saying here we have welded, here we have welded, here we have welded, here we have welded, and here we have put a rivet. Then what will happen? This all are in the triangular form, but it is a simple structure, a single. This when load will act, this all structure will move at a time. Then here the whatever the distortion will happen, that will be resisted by at this point by the bolt or frictionless pins. Or somewhere if this is increasing, that you are seeing in the breeze, that lots of triangular structures is there. And after a certain period of time you are putting the rivet. Then what will happen? Whatever the distortion will be there, that will be resisted by that one point, and that structure will move in this one directions. So this structure is designed to resist geometrical distortion under any applied loading. The ends are joined by riveting, welding, or by nuts and bolts. The bars are called the two force member because they are either in tension or compression. Because it is in a plane systems, because you have to analyze the plane structure, plane truss, and it is a coplanar. And you can analyze that it is a coplanar non-concurrent force is there. So if you will resolve it, horizontal and vertical component you will get. So two force member you will get, either you will get one side tension, one side compressions. Okay. Whatever assumptions we have discussed about that one, that is written here. Truss members are connected only at their ends. Truss members are connected by the frictionless pins. Trusses are loaded only at the joints. The weight of the members may be neglected. Means you have not to assume the weight of the rod, of the member. But practically it is not possible. But for your calculation, you have to assume. and the members are straight. These are the assumptions. Okay.
Yes, sir.
Next, classification of truss. Truss or frame. The structure is called a truss when the loads are applied at the joints and not only any other parts of the member. So I've discussed about that one. Truss, that it is acting only at the joints. The structure is called a frame when some of its members are subjected to two or more forces. These forces are applied not only at the joints but also at some other points of the member. Then this will be called as a frame. When it will be called as a truss, means load are applied only at the joints, means A, C, D, E, P. These are the joints because here two members are meeting. Here you are seeing three members, 1, 2, 3. So D point is a joints. So load will act only at the joints. So you have understood about the truss and frame. If it is a frame, means suppose that a rod is there, remove this one, and this is a straight rod, and here in the middle point some load is acting, then it is called a frame. If you remove the CE member and ED member, this member you remove, then it will called as a frame. Okay. So the machines are a structure that have some movable parts and used to transmit powers. Okay, that is. So based on the assumptions, each truss member is subjected to the forces only at the ends. Hence, member of trusses are two force member. Okay. Why it is called a two forces members? Is subjected to only at the joints, and the joints are, you have seen that it is inclined. See here, it is in. So one component and it is a plane system. So XY coordinate will be there. So horizontal force and vertical force will act. That's why it is a two force members. Generally, in a two force member, the force acts along the straight line joining the point where the forces are applied. The forces which pulls the member or tends to increase the length is known as tensile. That you take a pen, when you are opening the cover of the pen, how you are applying the force. One end you are keeping a straight, and for cap inside you are applying the force in the vertical direction. Means what you are doing, one force you are applying in the bottom direction and in the opposite top direction straight you are applying. Then caps are removing from your pen. So this is called the tensile force. So when the forces are acting to pull the member or to increase the length of the member, then it is called a tensile force. Forces which pushes the member to decrease the length or shorten the length, then it is called a compressive force. So forces in such a member is assumed as compressions. So you see here, AC is a member and AB is a member and BC is a member. And this is a triangular structure. Analyze the member AC. Because here it is a joint. You think it that from the joint, this is a straight rod. So from point A to in the C direction, force is acting. Now suppose that if it will acts in the C direction, so force from A to C, a starting point from where the starting joints from where the start, that you put first, and from where it is going you put in the second, in the suffix you put. So PAC denotes force is from A to C direction, and it is a rod, so it is going in this one direction. So at the point you see, imagine, so from C force is going into the A direction. So P, C, a starting point C and A going towards A. So from C point force CA will act. So you see here, this force is acting in this one direction, this force is acting in this one direction, but this AC member is straight, so both forces are the same, and one in the opposite and one in this one, both in the opposite direction it is acting, so the member will be become straight. If you will cut it here, then what will happen? This member, think about that one, think about the cap. So when you will apply this force, then what will happen? This will go in this one direction, so that it is showing here AC. Okay, so if this is coming in this one direction, so there is no distortion in the member, so this force will, if you will cut here, then you can show this is a free body diagram that PCA force will act in this direction and this acting in this direction. In the same way, from joint A, force is originating from A and terminating to the point C, so force will start from PAC. Whatever the value will come, if it is positive, then your direction is correct. If it will come value negative, then whatever you have assumed, reverse the direction. So in this direction it will come. So again you will cut it here, then this force and this force neutralizes, so the member are straight. In the same way, this joint is there, AB member is there. So imagine that force from A to B direction it is acting. So you write PAB from joint A, in this direction force is acting PAB. So this is a member cut into the member here, and from B point PBA force will be there. So PBA, PAB both are the same, and PAB, PBA both are the same because members are straight. All forces are equal. In the same way you see here BC. Okay, so this is called the free body diagram, and here ruler is there, so only vertical force will act PB because this is supported on the ruler joints. So in last class in the free body diagram we have discussed about that one, that if roller is there, so only reaction force will be the vertical, and here it is hinged. So when it is hinged, so only horizontal and vertical force will act at the reaction point of A. So HA, VA will act out at the hinge joint, and on the roller this force will act. So this will become the free body diagram of a triangular truss. So tensile force in the member, force acts away from the joint. Initially you have to assume that if you are not knowing, if the problem it is not given, then you assume in each member that it is a tensile force. In each member tensile force are acting. Okay, so in each member tensile force are acting, so you show from the joint in the upward direction. From joint you take it, the tensile force is acting from the joint A to which joint you are selecting, then you take it PAB, means force are tensile force are acting from the point A to B, and compression force are acting towards the joint, towards the joint. Please wait for some minute.
क्या हुआ सर?
If you will get the value your negative, then you tell that it is a compressive. I will show you how you have to write, how you have to calculate. Just I am refreshing you and bringing you in the systems that what is a truss, what is this one things. So for your syllabus, you keep in this one mind that assumptions, and keeping the assumptions in your mind that you have to calculate only the force in the member and load are acting only at the joints. Just this you have to keep in your mind. A truss is a systems which has been made by a triangular way. Suppose that it is a parallelogram. So this will not become a truss. You have to join by this the diagonal so that it will become into a 3 because it will become in a triangle. Here is a equation for that one. Okay, I will discuss about that one. There is a relation between these things. Okay, so I will go also to that one. Okay, so suppose that take the member is M. Okay, take the member is M and joint you write J. Okay, so if M plus 3, that I will discuss later, because if I will discuss here then it will become problem for you. Okay, so that the degrees of freedom and this one things I will discuss later. First I am briefing you what is a truss, what you have to do, what you have to calculate. So free body diagram of the joints of a member, for that one I am discussing about. So this way you have to see, not this way, because see here joints and we are removing the joints, not showing. Joint is there but force is away from the joint. Indicating point and these points you are not showing. So remove the, here also the structure is there, reaction surface is there, or suppose that ground will be there or pillar will be there or something will, roller will be there, but I am not showing. That will adjusted by only a force, that is the reaction force BB. This is the free body diagram. Here is the hinge is there. I am not showing here. I am showing only the force BAHA. So when you are drawing the free body diagram by the forces, showing the forces, you show the member is in equilibrium condition. So tensile force in the member, forces acting away from the joints, and compression when the forces are acting towards the joint. Okay, if you will reverse the direction, then forces are coming here to V point, then it will become a compressive force. That depends upon your assumptions. If you will assume that it is a compressive, then it is a compressive, and if it will come the negative value, so change the direction. So for analysis of the truss, analysis means calculating the forces in the member when loads are acting at the joints. And why you are calculating the forces in the member? Because by that one way you are able to give the diameter of that one rod or thickness of the member so that it is able to sustain. That you are seeing that lots of bridges are constructing, and if they will not calculate the actual load calculations, and then when they are putting the structure beams on the pillar, and pillar gets collapsed. So here is some calculation and some wrong calculation is there. That's why you are putting the load more and your material strength is very weak. That's why they gets collapsed. So truss may be considered as a group of two force member connected at their ends by the frictionless pins. So whatever I am discussing about that one, So to find the forces in the member, there are two methods: method of joints and method of sections. You have to study both. You have to calculate the forces in the member by the method of joints and by the method of sections. So one by one we will discuss. First we will discuss about the method of joints, and then we will discuss about the methods of sections and what is the difference between the two. You can solve the problem both ways, answer will become the same. But where you have to, if in the problem it is written that you solve by the method of joints, then you have to solve. But if it is a large structure, and if you will suppose that the 1000 joints is there, and if you will solve one by one, so it will take 2 days, 3 days to calculate the all forces in the member. So to minimize that one, methods of sections is there. But you have to know both the method. Okay? Dikshit? Dikshit,
Yes, sir. Yes, sir. I am listening.
is it clear to you?
Yes, sir.
So first we will take the methods of joints, then we will go for the methods of sections. So truss may be considered as a group of two force members connected at their ends by the frictionless pins. Since the entire truss is a rigid body in equilibrium, क्योंकि ब्रिज तो कोलैप्स नहीं कर रहा है, आप कितने टन भी वेट लेके जाइए तो systems are in equilibrium. Each part is also considered to be in equilibrium. The method of joint consists of taking the truss into number of parts, drawing free body diagram for each member and joints, and applying equations of equilibrium for each part. क्योंकि स्ट्रक्चर इक्विलिब्रियम है, रूफ टॉप है, तो इक्विलिब्रियम में है, हवा आने से तो उड़ नहीं जा रहा है, यही अपने से वो ट्रस स्ट्रक्चर तो नीचे नहीं चल जा रहा है, ब्रिज है तभी आप उस पर चल पा रहे हैं, तो सिस्टम आर इन इक्विलिब्रियम. So truss members are subjected to axial force only. The symbol Pij is used to represent unknown force in the member Pij, means starting from the joint I and directing towards J joint. So forces in the member is written Ij. So Pij and Pji both are the same. Only subscript order changes, and it shows that forces are going from joint I to J or from J to I. So you have in the assumptions we have assumed it, forces in the member will remain the same. So if it is Pij or Pji, both are the same. Okay, that you have to keep in your mind, no confusions should come. Pij denotes the force represented at joint I towards joint J. I have discussed. All the members are assumed to be in tension. That is the assumptions. If you are not assuming, if you will assume compression, assume it, answer will become negative. Then you tell that this force is a tensile force. Force that acts away from the member or joint is called the tensile, which tends to increase the length. Equilibrium of joints ensures that summations of all the forces is 0 for each joint. Positive value of force is tensile, negative value is compression in the member. Each joint consists of concurrent plane truss. Each joint, keep in this one mind, each joint is a concurrent coplanar forces that you imagine for each joint, coplanar concurrent force. So equilibrium of equations you apply here, so what you will write? Summation fx is equal to 0, summation fy is equal to 0. So steps in methods of joints. Okay, so I think time is approaching, so this we will discuss in the next class. Okay, Praveen?
Yes, sir.
Sir, yes, sir.
Yes, sir.
This we will discuss in the next class. Okay.
Okay, sir.
Okay, sir.
Okay. Thank you.
Thank you, sir.
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 Yes, sir.